Okay, we're going to start chapter 9 on rational expressions. This is section 9.1, reduced rational expressions. So what are rational expressions? Well, they're either a ratio of two polynomials, if you want to look at it that way, or it's basically a fraction where the numerator and denominator are both polynomials. Now we can evaluate rational expressions by just plugging in the given value into the rational expression and then simplifying. And here are two examples. So they ask us to evaluate the expression for the given value. And so what we're going to do is we're going to plug this minus 4 in place of x in this rational expression. So when we do that, we're going to have a minus 4 minus 3 over, and then we'll have a minus 4 squared, minus 4 times 4, minus 4, and then plus 3. So a minus 4 minus 3 is a minus 7. And here we have a 16, and then plus 16, and then plus a 3. So that gives us a minus 7 over, here's 32, 33, 34, 35. And now we can reduce 7 will go in here once, 7 will go in here 5 times, and so then we get the final answer of minus 1 over 5. All right, so that's all we do for plugging in expression values. And so now we have n is equal to 4, and we plug this into the rational expression n squared minus n minus 6 all over n minus 3. And when we do that, we get 4 squared minus 4 minus 6 over 4 minus 3. So that gives us 16 minus, and 4 minus 6 is 10. And that's all over 1. 16 minus 10 is 6, and over 1. And so that is just 6. Okay, so again, just plugging in values, doing the math, and coming up with a simplified answer when we get done. Now, when rational expressions are written, they're undefined when our denominator is equal to 0. So what we need to do is we need to determine what values are excluded in a rational expression. And the way we do that is we set the whole denominator equal to 0, and then we solve the equation for the given variable. Sometimes we can, unlike this one, we can just take, the 25 to one side, divide by 10, and we get our value for n. Others, like the last two, we're going to have to factor the trinomial or the binomial, set those equal to 0, use the zero product rule, and solve for each of the two values. And then after that, those are our excluded values. So looking at our first one, all we have to worry about is that denominator, because we're looking for excluded values only. So we take 10n plus 25 equals 0. So subtract 25. And so we get 10n equals negative 25. Divide by 10 now. And so n is equal to what? Well, that can be reduced. And 5 will go into here twice. 5 will go in here 5 times. And so our final value is actually a minus 5 over 2. And so that is the excluded value. Okay, so this one just has one excluded value. And we would expect that because we have just a 1 on our value for n. Now here we have a squared, so we're going to expect two values. So what we do is we set that whole thing, b squared plus 4b minus 32 equal to 0. Now we get a factor. And so what do we have? Well, b squared, that's only b and b. Now we have a minus, so that means one's plus, one's minus. And two factors of 32 that when subtracted give us 4. Well, 8 and 4 will work, and we need the larger to be positive because our center is positive. So that's b squared minus 4b plus 8b, so it's going to be plus 4b, and then minus 32. Now we set each of those factors, b plus 8 is equal to 0, and b minus 4 equal to 0. And so b equals a minus 8. And over here we have b is equal to 4. And so this one, like we assumed it would be, we have two excluded values. Okay. Now in the next one, we set that whole thing equal to 0, 18p squared minus 36p equals 0. Now here, it looks like we have a GCF. So what we need to do is pull out that GCF. So 18 will go into both of those, p has something in both of them. So we're left with a p minus 2. That's equal to 0. So now we set both of the factors equal to 0. And then p minus 2 equals 0. And so here we get p equals 0, and here we get p equals 2. And these are our two excluded values. So those are the values that cannot be a solution to this, because that would make our denominator equal to 0, and we cannot divide by 0. Now, when we have rational expressions, sometimes what we need to do is we need to simplify them as much as possible. And so when we look at ones that have just monomials, such as, maybe 3x over 15x squared, what we're going to do is we're going to divide out common factors in the numerator and denominator and cancel. Now, the way we're going to do this is we're going to look at it this way. If p and q and k are non-zero polynomials, then if we have p times k over q times k and it's a rational expression, then we'll have the following. We can cancel out the k's because those are common factors, and we just get the p over q. So in our example up here, if we have that, what we can do is, well, we can say, well, one of these x's cancels one of these. We're left with 1. That 3 will cancel in here 1. We'll have 5. And so then that gives us the simplified expression. Well, this all cancels to 1 in the numerator, and this gives us 5x in the denominator. And so that's how we're going to do it for monomials. Now, a rational expression is irreducible if there are no more common factors among the numerator and denominator. So as we can see here in our example, we can't reduce anymore. P over Q, there's nothing in common. We can't reduce anymore. So those are both irreducible. Now, when we reduce fractions with polynomials, what we do is we have to first factor both the numerator and the denominator. So you're going to get really good at factoring here. And then you cancel out any factors that are in common, and then you can reduce it and have your final rational expression from there. And so now what we're going to do is we're just going to do a bunch of different types and examples, and that's going to be kind of what we do now. And so looking at this, if we go ahead, and that one is going to be, nothing we can do here as far as factoring. So 8 will go into 8 once. 8 will go into 32 4 times. Now 3 of these x's cancel 3 of those, and we're left with 1. And so that gives us then the final answer. Looks like 4 in the numerator and just x in the denominator. And so that is that monomial over monomial reduced down to lowest terms. Now this one we have to do a little bit more work. The denominator we actually have to factor if we're going to cancel anything. So if we look at that, the GCF is 2, and so what's left over after we factor that is 2p plus 1. And now what we can do is we can go ahead and factor, and 2 will go in here once, and it'll go in here 10 times, and now we've reduced it as much as we can, and we end up with 10 over 2p plus 1. Okay, so these are simple examples to kind of get your mind thinking how to cancel things out. Now here we step up a notch and we have a little bit more to do. So on the first one, numerator, I don't see anything we can do there. That's just a monomial, so all we do is rewrite it as a monomial. Now the denominator is kind of like the last one. We can factor something out. What we can factor out is the 5. And we're left with 2n plus 5. If we multiply that back out, that's 10n plus 25, so that looks good. Now what we can do is we can do our factor or canceling. So that 5 will cancel and leave us with 1. And here, that'll leave us with 3. Nothing else is factorable out or cancelable. And so that gives us 3n squared over 2n plus 5. And that's our final reduced rational expression from the one we started with. Now the next one, we take it up another notch. We have a trinomial over a binomial. And so that means we're going to have to probably factor that trinomial if we want to cancel anything out. Now what I'm going to do is I'm going to do the denominator first, because sometimes once you do that, that'll kind of give you a hint of what you can factor in the numerator. So I do the denominator here first. I pull out a 5, and I'm left with r plus 2. Now I see that there's no factors of 5 here, so I'm going to assume one of these is going to be r plus 2, because usually we're going to cancel something out. So if I have r plus 2 here, what's left? Well, the only thing left is r plus 1 because 2 times 1 is 2. Now let's check and see if that really works. R squared plus r plus 2r, so that's 3r plus 2. So that gives us our trinomial back. And so now what we can do is we can cancel. And so our r plus 2 cancels our r plus 2. And then what we have left over is just r plus 1 over 5. Okay. So whenever you have a trinomial, sometimes it's easier to factor than binomials, or if there's a trinomial that's really easy on one side, the numerator or the denominator, do that one first, and then the other one, sometimes you can use one of those factors as your starting point, and then you can get the other one a lot easier. Okay, so looking at our next one, number 5, I see that the numerator has a factor of 9 I can pull out. And this next one, I see that 60 has a lot of ways I can factor 60. So trying to get the one to get 4, I'm going to try the numerator first. So I'm going to pull out a 9, and that gives me a v plus 6. Okay, so what I'm going to do is I'm going to say, well, let's try v plus 6 as one of our terms. Another one's going to be v. And now how to get to minus 60, I'm going to have minus 10. Now if I multiply that back out, that's going to give me v squared minus 10v plus 6v, so that's going to be minus 4v, ta-da, and then minus 60. And so now what I can do is I can cancel out my v plus 6, which is what I assumed that was going to happen, and then that gives me my final rational expression that is going to give me 9 over v minus 10, okay? All right, so the next one I see, I have two trinomials, so I'm going to have to factor numerator and denominator. Now, the first thing I notice is 2 is a factor in each one of those. So I'm going to factor out a 2 first. Then I have x squared minus 5x, and then plus 4. And then over the denominator, well, that one, it's going to be one of those that might be easier to factor the numerator first to figure it out. But I'll go ahead and do a 3x and x. That's going to give me the 3x squared. Now what factors of 4? And they both have to be negative because we have a plus here but a minus here. And now what factors are here? So we're going to add them. Well, if I look here, 4 plus 3 is 7. So if I put a 4 here and a 1 here, that goes to give me 3x squared minus 3x minus 4x, which is minus 7x, and then plus 4. Okay. Now I still have to factor that numerator, so that's going to give me 2 times. And then I already have the denominator factored, 3x minus 4 and x minus 1. And you know what? I'm going to go ahead and say, well, hey, you know, I bet one of these is x minus 1. So what's the other one going to be? Well, to get that to work, that has to be a minus 4. And I would know that it's going to be negative on both of them because that's positive, that's negative, so it has to be negative, negative. And so now I have x squared minus 4x minus x, so that's minus 5x, and then plus 4, and that's what I need. So now we're down to just being able to cancel things out, which is a more fun part than factoring. And so basically those cancel, nothing else will cancel out. And so now I can write out my final rational expression of these two, and that's going to be 2 times x minus 4 all over 3x minus 4. And I can put it in parentheses as well if I want to do that. All right, so that's how I would do this one. And again, you know, we could have done it all the way across the top and factored that one first, and then the next one I could have made it easier because I would have found the x minus 1 and done that one, or we did the denominator first and then found the top one easy that way. All right, so let's see here. The denominator looks easy. I have a GCF of 6 I can pull out, and that's going to give me n plus 1. Now the numerator, well, you know, this one doesn't look like there's going to be much canceling because I have a minus here, a plus here, so I have to have 2 minuses. And I'm going to have n minus 1 times n minus 1, and that'll give me n squared minus n, so minus 2n plus 1. So if we notice, nothing cancels. But I'm going to leave it in this form here because that way I know that if I put it back in here, I'm going to have to see, oh, well, what does that factor out to know if it cancels or not. And so this is the factored form. I'm going to leave it in. You always leave your final answer in factored form, and that would be what I have. All right, moving on to the next one there. I see some common terms in numerators and denominators. And so what I'll do is factor out the GCF first. It looks like 2k is the one for the numerator, and that leaves me 2k squared minus k, and then minus 1. And so that gives me 4k cubed minus 2k squared minus 2k. So that looks good. And here it looks like 9k is going to be my factor. And if I pull that out, I have a k squared minus 2k and then plus 1. So that's 9k cubed minus 18k squared plus 9k. So now what I need to do is factor those two trinomials. And so that gives me 2k times that over 9k times, and I'm going to leave those k's. I see they cancel, but I'm going to leave them until the end so I can cancel everything in one step. All right, the first one here I have 2k and k, and then my factors are 1 and 1, and now I have to determine which one is going to be the negative. So the larger one has to be negative, so that has to be this one, because if I take that times that, it's going to be a minus 2k plus 1k gives me a minus k. Now in the denominator, they're both going to have to be k minus 1, because that's the only way I'm going to get this one. It has to be minus times a minus to get the plus, and when I add those together, that gives me the minus 2. All right, so now I'm at the stage I get to have fun and cancel, so the k cancels a k, and a k minus 1 cancels a k minus 1, and so now I've reduced my rational expression to 2 times 2k plus 1 over 9 times k minus 1. And then that would be my final answer. All right. Next one here. So in this one, I see that I have a lot of terms that have common factors, GCFs in them. So up here, it looks like both of those have a factor of 8. And so 8 times 7 is 56. Then I have x. Then 6 times 8 is 48. And so that would be my numerator factored. But my denominator looks like 8 again is going to be a factor. That gives me 3x squared plus 7x, and then plus 4. Okay, 24, 56, 32. All right, so now the numerator, it can't be reduced anymore, so that is left alone. Now the denominator, though, looks like we maybe can reduce it. So that's 3x and x. And so then we have to add to 7. So 3 plus 4 is 7. So if I put a plus 4 here and a plus 1 here, that gives me 3x plus 4x is 7x plus 4. So that looks to be my factored form completely. Now, what can I cancel? Well, 8 cancels 8, nothing else. And so that one really, after that first step, was really all done, but we had to go ahead and factor to make sure. And so 7x minus 6 all over 3x plus 4 times x plus 1. And again, we'll leave it in factored form. That way we know that there's something we didn't miss later if we turn it in. All right, what about this next one? Well, it looks like we only have GCFs that we can pull out here. The numerator, we can pull out a 35. And what does that leave us? V plus 1. Now the denominator looks like a common term is 7, and that leaves us with 3v plus 1. All right, so what can we do? Well, our binomial pieces, they don't cancel anything. So, but we see 7 will go in here once, 7 will go in here 5 times. And so that's all we really could do in that whole thing. And so we get 5 times v plus 1 over 3v plus 1. And that's our final value. So that's all we can do. And that's what we're going to have for the reduced form of this rational expression. All right, so that's all I have for this section.